Here we go. So number 11. So the exam we're taking is going to be on the travel stuff and the money stuff. So here we go. Example of an optimal and efficient algorithm for the traveling salesman problem is. An example of an optimal, right, gives you the best answer and it's fast, has not yet been discovered. It may be. Who knows? That one's, wasn't like the other chapters where it's been proven it'll never exist. It wasn't that. It just hasn't been found yet. So they're always trying to get better and better ones. Number 12. Brute force is optimal, inefficient. Yep. 13. A complete graph with 12 vertices. 12 vertices. So it's going to be, 12, it's going to be 12 minus 1 factorial, meaning 11 factorial. There we go. All right, so we have all those, right? So number 11, we've not yet been discovered something that's optimal and efficient. Brute force is optimal and inefficient. Complete graph with 12 vertices has 11 factorial. It's n minus 1 factorial. So now to number 14, cheapest link. What's he?
Not
optimal. Cheapest link. So only brute force gives you the best answer, but it's slow.
So it's not A or D. No.
So it's not optimal. It's not optimal, right? It's approximate means not best, right? If something's an approximation, it's not exact. You with me?
It's C.
Is that word confusing for you?
Isn't it B?
It is, yeah, B. Right, does that make sense? Because it's approximate, meaning it's not best. It's not exactly the best. It's close to the best. It's approximate. And it's efficient. It's quick. B. Yeah, exactly. That's why I give you the practice exam, so you won't be surprised on test day. So Kate decides to replace all the light bulbs in her college apartment, energy saving, blah, blah, blah. Package says 75% less electricity. Her bill was $725 last month. Project her bill this month.
Assuming that's true.
Yeah, now, what the battle on a math test, a lot of times, identification. That's one of those things on the sideboard over there. But it's kind of hard to tell sometimes, because they might not be using the exact same words, it's the same concepts. What idea of what we did, it's not today's stuff, it's from yesterday actually. It's 10.1. Look at the 10.1 section. What concept is it over there?
What would be a decrease?
It's a percent increase, decrease. Yeah. Because they're saying, right, 75% less, that's a percent decrease, isn't it? So remember the percent decrease formula. How do you do it? It's on the sideboard still. The new bill is going to be 1 minus the percent times the old bill. It's a percent decrease. Will you recognize that now? You've seen something like this on the exam Tuesday? So let's do it. So the new bill, that's what they're asking me for. Find this month is equal to 1 minus, what's the percentage? What do I put in? 75, but how do I put it in? Decimal. Always decimal. So 0.75, right? Whenever we stick percentages in. Decimal. What's the old? 729. That is...
Isn't that bad for college?
Bad for college?
The electric bill, that's not that bad.
Oh, yeah, it did. Doesn't seem too bad to me. All right, so then subtract this on your calculator to get 0.25 times 7.29. Hit the buttons. And I'm thinking $1. Is that what it is? $1.82. So there it is. Option C. Makes sense how we do that. So percent increase, percent decrease. Be looking for it. A lot of it's the battle of identification to know which formula to use on which problem. On we go to number 16. Questions on that one? That coming out?
Oh, no, good, yeah.
The groundhog population of Punxsutawney. Where they're? You remember that's a famous. Yeah, I think so. Remember what movie? Do you guys remember what movie? All All right, so anyway, groundhog population, Punxsutawney, yeah, they're famous for that. It's closely monitored each year. So 2 years ago, population decreased 12%, then increased 6%, increased 9%. What's the final thing? Remember we had one just like this in the homework with the stocks going up and down, up and down, up and down. What do? 1 plus, 1 minus, multiply them all together. Yeah, so let's do it. So I'll write decrease, that's minus 0.12, and increase, that's plus 0.06. And what's next? Increase, 9%, that's plus 0.09, and the whole thing. Okay, so you got to put a 1 with each of those, right? So 1 minus 0.12 times 1 plus 0.06 times 1 plus 0.09. So use your calculator, that'll be 0.88, 1.06, 1.09. Crank it out. Somebody got a number on their calculator?
I don't think it's right.
To just multiply those three together? Not coming. One more time, you got 1.016.
Yeah.
Give me
There's more.
a little bit more, yeah.
752.
752. Great. Now, what do we do with that answer? I don't see 1 point over here. What do you do?
Take the 1 away.
Remember, you cut off the 1 because the $1 or the 1 is just the original. You cut off the 1, move the decimal 2 places because we got to make it a percentage. See, all the answers are percentage. So it's 1.6752%. Which now these are all rounded. Notice. So which one rounds correctly? 1.7. 1.7. Does the rounding confuse you? Right? If they have the numbers rounded, then you just find the one that rounds correctly. Right? It rounds to 1.7%. So that's a 1.7% increase. Right, good. Remember how that works? All right, let's move on with number 17. Suppose that, feel free to write any of these on your 3x5 card, right? If there's a especially difficult one, write the whole thing out. Suppose that $543 is invested in a savings account with an APR of 8.75% compounded annually. What is the future value of the account in 4 years?
Okay. So you do the
So on number 17, so it's one of these kind we've been doing recently. And now, ask yourself, is it a series of payments? Are there several times they're putting money in? Or do they just put money in once? Yeah. 543 is invested. Period. One time, huh? It's not 543 every month or something. It's just 543 once, and then you let it sit for 4 years. So that's the compound interest formula, isn't it? It's not either one of the new ones we did today, future value or present value. Now, it can confuse you. You might say, wait a minute, but they said future value there. Yeah, that's why you can't just be going on words and the appearance of things. You have to go by what they really mean and what they really are.
So it's the one with the A equals P.
Yeah, A equals P. Yeah, so that's what we're going to use. Everybody see that? So we're going to use A equals P, 1 plus R over N to the NT. It's compound interest because there's only only one investment. They only invested one time, didn't they? All right, so I'll bring it up here. So number 17. What is it there? So number 17, it's 543, 8.75%. 543 at 8.75%.
annually. So
8.75 annually. Compounded annually. Right. So it's A equals P, 1 plus R over N to the NT. So the P, that's the 543, right? That's the money they invested. The interest rate, move this back 2 places, 0.0875 over N. What's the N?
1.
Yeah, annually is just once a year, like a birthday. The time?
4.
Oh, I forgot that part, huh?
I think 4 years.
think you're right.
Oh, 3. Oh, wait, 4. Sorry.
4 years.
Wrong question.
So I'll write that
That's
down.
what your grandma said.
4 years. So that goes there. So 1.0875 to the fourth. Hit the buttons. Did you guys get it? You said it's A? 759.48?
Yeah.
759.48. We good? We feel like you could recognize that, tell that from one of the payment problems? It's just a one-time investment, isn't it? Just a one-time investment, not a several time. Okay. Right. So 18. Suppose that $5,000 is invested in a savings account with an APR of 8% compounded monthly. What is the future value of the account in 10 years? Okay. So is that a series of payments, or is it a one-time investment? One time, huh? No payments. One time. Yeah, so you know it's a compound interest formula again, isn't it? One-time investment. So it's A equals P, 1 plus R over N to the NT. So amount, the 5,000 is the principal. The interest rate, 8%, 0.08. The N,
12.
good, compounded monthly, huh? N is 12. T, 10 years. Like that. So type that, and I would go ahead and find the power out right now. That's 120, right, on your calculator. Use that. Crank it out. Somebody got an answer on that one?
11. It's the 11.
It's the C.
C.
11,098.20. Good?
Yeah.
So 18 is C. Right. Let's keep moving. Okay, so 19. Bank offers a 6.35% annual interest rate compounded daily. The APY is approximately?
Is it a trick question?
No.
I don't know.
I know, because you think, well, annual interest, what's APY?
Something for you.
Where you put the dollars and
Yeah.
how much it makes on the one.
Oh, that.
Right? Remember that? Remember that rates aren't exactly what they seem to be. Right? So if they compound money more frequently, it makes the rate go higher. That's one of these. That's find out what the rate really is. Remember, truth in lending laws say they've got to put this on loans. They got to tell you what the real rate is. So to find APY, APY stands for yield, annual percentage yield, meaning what the thing really does, what it really yields. To find that, we've got step number 1, put in $1, put in, well, I should say, P equals $1 for T equals 1 year.
It would still be.
Into the same old formula we've been using. Yeah, because it's still just a one-time investment, right?
Yeah.
We're not talking about series of payments, right?
Is it the same one?
So let's do it. So we take that formula and we say, okay, the amount is going to be P is $1. So we're saying put in $1 for 1 year. Because if you can find out what happens to $1 after a year, you'll know what happens to every dollar. You'll know the real effect that account is having on your money, right? That's really what annual percentage yield is. You know what it's really yielding. Find out what $1 yields, and you know what every dollar yields. You'll know the yield of the account. So the rate, the interest rate, at least the listed one, Decimal back 2 places, right? Boom, boom. 0.0635 over n.
1, right? Because it's over 360.
Oh, 360.
Because it's compounded daily.
Compounded daily.
Okay, right.
So 306. So n, that means n is 365, remember? So they're saying compounded daily. That's the whole point. If it was just compounded once a year, the listed rate would be the rate. There'd be no difference. But if it's compounded more frequently, that changes the actual effect, the yield. So 365 to the 365 times t. And what's t? Yeah, it's always 1 year because we're trying to find out what does this account yield in 1 year? Annual percentage yield. What does it do in 1 year? Hit the buttons on the calculator. And what do we get?
6.5.
Did you get, so you got 1.065,
5.
just but fives forever?
Yeah, no, three,
Well,
yeah, 3
3, 6,
5
0,
and
1.
3 6 at the end.
3 5s and 3 6 like that.
3 5 and 3 6.
Yeah. It's going to be 80.
Okay, yeah. So remember what we do now. How do we finish up the answers? We always
Take off the
cut off the one because the $1 became a dollar whatever, and all we care is what it yielded. We don't care about the original dollar, just what it yielded. And then, so this is the decimal yield. What do you do to change this decimal? Move it 2 points to get a percentage yield, a per 100 yield, divide by 100 effectively. So 6.5536%. Which answer does that round to be? Oh, wait a minute. Is that right?
A? Yeah, because 5 is.
No. Do you guys tell me the exact? Is this really the decimal? Exactly.
Oh,
One,
5, 5, 5, 3,
in the
6, 0, 1. If you want to really go that far.
So this should be
On
6.55.
the bottom.
What's that?
Yeah, you're missing 1
You
5.
miss. You need on the bottom.
Oh, thanks. That's important, isn't it? I'm messing up. Thank you. I was showing you how easy it is to mess up. All right. So, yeah, so then that'll round to see this spot, look one to the right, it rounds, doesn't it? 6.56%. There it is. 6.56. We good there?
Yeah.
So there'll certainly be an annual percentage yield problem. Find out what an account really does. Right? And it's always going to be higher. By the way, you could have just laughed at that answer, huh? Because annual percentage yield is always higher than the listed rate, not lower.
Right.
So if you know that, you can just laugh at that one for sure. That's not it. All right. Addie plans to send her newborn daughter, Kara, to a prestigious ballet school when she turns 6 years old. Addie's goal is to create a trust fund worth $50,000 in 6 years. If she plans to make deposits at the end of each week into a trust fund earning 4.82% annual interest compounded weekly, how much should her weekly deposits to the trust fund be? Okay, so is this a series of payments?
Yes.
Yeah, she's putting in money every week. Right? Now, is it future value or present? So let's go through the thinking, because this is a lot of the battle. They're going to be all mixed up on Tuesday's test.
Because when she
Planning
said,
for her.
Right. So it's a series of payments, isn't it? It's not just a one-time investment.
I was like, wow, you're already planning a newborn daughter.
Yeah, it's a little crazy, huh? Yeah. So it's a series of payments, not just a one-time. So it's one of the two annuity formulas, either future value or present value. Which one is it? Is she planning to? Is she getting? Is the big pile of money now, or is the big pile of money later? Later. So it's future value. The pile is later. The big pile. The big pile is later. She's trying to save up for like 6 years from now. Okay. So future value formula is equals P, big old bracket, 1 plus R over N plus R over N to the NT minus 1 all over R over N. Good to there. So I'm going to go to a fresh screen here. So for number 20, so she wants a $50,000. She wants $50,000 in 6 years. 4.82%. Compounded weekly. Did you notice the compounded weekly? That's different than we've done. How many weeks in a year?
352. I mean, 52.
That's a lot of weeks.
It's been a long day.
52
More
weeks
days.
in a year.
Long day for me.
Brooks, weeks are short though, but long days. All right, so 482 annual interest. So compounded weekly. Yep, that's it. So payments
What did you get?
each week.
108.27.
Okay, I'll see that.
Okay, so let's.
Because then you have to divide your answer.
Okay, so the formula P 1 plus R over N to the NT minus 1 over R over N. So let's plug stuff into it. So do we know the future value? Yeah, that's the 50,000. Huh. That's what she wants in the future. So that's the 50,000. Do we know the P? No, the P is the payment. What she wants to, what she needs to put in the account every week. She doesn't put money every week. She's serious about this. Every week. And the interest rate, 4.82. Move it back to 0.0482 over N. What's N? 52. 52 weeks about in a year. It's close enough. In 52 time is 6 years, right? Time is always in years. Always in years. Minus 1 all over 0.0482 over 52. All right, so on your calculator, remember what you do? Start right here on, first figure out this power. What is 6 times 50 to 312?
Yeah.
So figure that out first. That power right there, 52 times 6 is 312. So then start on the inner area, inner parentheses. Good there, minus 1 equals, and then you got to grab that denominator right here.
So then that gives you,
I think
it's
that's
like,
what I did.
it's like 360.
You got to flip this upside down.
I forgot to do that last part. Okay, good. I don't feel that.
So I was like, hang on a minute. I'm stuck.
Is that good? You got to take that denominator and flip it up, right? Because dividing is upside down multiplying. So you got to multiply by the upside down of that. So multiply by the 52. Divide by the 0.0482. Multiply by the 52. Divide by the 0.0482. And hit equals. it equals, when you're done there, okay, so when you do that, you get 50,000 equals P, and so what becomes of that whole bracket number?
361.
Uh-huh.
Point 60, 48.
6048.
Yeah, like 60, 48, 86, and then 3.
Okay. So we getting that? So that whole bracket number becomes that. And how do we finish solving for P? Divide it by that big old 361, 604, 8863, both sides. Or you could just use the answer button if you have one of those on your calculator. Boom. So, what do we get there?
$138.27.
$138.27. Hope that answers there. Yeah, it's A. $138.27. That's not too bad. $138. Well, it's every week. It's car payment again. So it's 4 times in a month. That's like over $500. It's a nice car payment. So, for her daughter to ballet away. All right. So you decide to save money to buy a new fishing boat by opening a special account at a bank that offers 8.2% APR compounded monthly. You deposit $450 at the end of each month for 48 months. How much will you have in your account after 48 months?
That's
So is it a series of payments or is it one-time investment?
no, it's at the end of each month.
You deposit $450 every month. So it's series of payments, right? So it's not one time. So it's one of our future value, present value formulas. And where's the big pile of money? Now or later?
Again, later.
Again, later. That's again the future value formula, isn't it? That's the future value. The big pile is later. You want the big pile later to buy the fishing boat. That'd be the opposite of just buying the fishing boat now with a big loan. That would be present value, and we'd be doing a different formula, right? But instead, they're saving up for the fishing boat. All right, so let's crank it out. So 21, let's write down the details. So you're going to 8.2% compounded monthly. 8.2% compounded monthly. And $450 each month. $450 each month, and 48 months. 48 months. 48 months. Okay. So we use the future value formula. All right, yeah, so watch out on this one. 48 months, T is 4 years. Yeah, the T has to be in years when you use all these formulas. T is always in years. So they'll try to trick you by giving it to you in some other form. T is 4 years. So future value is P, the principal. $450. That's the payment, I mean. That's the payment. $450. The interest rate, 0.082 over N. What's the N here? 12 every month. Compounded monthly. N is 12. The time is 4 years. And we start by figuring out the power. 4 times 12. There's that 48. 48. So we take our calculator, start with the inside. 1 plus 0.082 divided by 12 equals 2 to the power 48 equals minus 1 equals, and then you have the whole numerator at that point, and then you just grab that denominator, and remember dividing is upside down multiplying, so flip that thing up. It's times 12 divided by 0.082. So we go times 12 divided by 0.082. It equals, oh, and last step, times, I almost forgot, the 450 in the front, huh? Don't forget about that 450 in the front. Got to multiply by that. Get an answer that's way off. So which one is it there?
What number?
25,461, so B.
B. There it is. 25,461. So the answer is 25,461. 74. So that's how much would be saved if you put $450 away each month for 4 years at 8.2%. You'd save up $25,000.
So if it had a weird, like, 8, okay, so if it had 8 months instead of, like, you know, the 48.
His family just bought a house. They made a $40,000 down payment and financed the balance with a 30-year home mortgage loan with an interest rate of 8% compounded monthly. Their mortgage payment is $900. What was the selling price of the house? Rounded to the nearest dollar. So yeah, we know the home loan, car loan, that is present value, right? You get the money now. The bank loans you the money now to buy the house or the car. So that's certainly clearly present value. So number 22. What are the facts? They put $40,000 down. $40,000 down. Financed the balance. Financed. $40,000 down. Financed the balance. 30-year loan. 8% monthly. 30 years, 8% monthly, $900 payment. So and what's their question? The question is, what was the selling price? Selling price of the house. All right, so how do we figure out the selling price of the house? So we're going to use the present value formula because we get the money now. So P bracket present value 1 minus 1 plus R over N to the minus NT over R over N. So there we go for that. Okay, so let's plug it in now. Yeah, let's forget about that 40,000. This one's got a little one extra step. It won't be bad. We'll handle that at the end. Just forget about the 40,000. Just do the rest of the stuff. So what's their payment? The P, that's the 900. That's the payment. All right. So that's the 900 payment. 1 minus 1 plus their interest rate, 8%, 0.08 over the N. What's the N?
12.
Yeah, N is 12 again, monthly. To the minus N times T. What's the T? 30 years. T is years. It's 30 years. Over 0.08 over 12. Like that. Okay, so let's crank that out on our calculator. Remember, we gotta get this power first. This is minus 360 up there in the power zone. Minus 360. And so then we start right here. We go 1 plus 0.08 divided by 12 equals to the power. And you got to use the negative. Make sure you know the negative is different than the subtraction. The calculators get really upset. At least the TIs do. 12, negative 12, or negative 360, huh? That power is negative, it's right here, negative 360 equals to that power. And then, right now, so far, I've got all of this, don't I?
Yeah.
So you got to do 1 minus the answer. If you have an answer button on your calculator, that's a convenient way to go. If not, you got to write down that answer, and they go 1 minus it. So 1 minus the answer, 1 minus the answer, hit equals. So now we've got this entire numerator, right? We did the 1 minus. Now you've got to take this part and flip it up, because dividing is upside down multiplying, times 12 divided by 0.08. So times 12 divided by 0.08. And then don't forget about the 900 in the front. Times 900 equals. All right, what'd you guys get for that?
122, yeah.
122.
655 and 14 cents. Yeah, I don't want to be wrong.
Yeah, okay, so that looks good. You're both getting that. So now,
We add the 40,000?
yeah, now let's think about the 40,000. So what is this $122,000 number?
That's the interest.
That's the loan. That's everything they paid for the loan. Well, that's the present value, I should say. That's not everything they paid. That was not a true statement. That's the present value, right? That's the left side. That's over here. That's the present value. That's the loan they got from the bank. Well, in addition, they put $40,000. So what did they pay for the house?
Of their own.
They put $40,000 of their own dollars, and then the loan that the bank gave them paid the rest of the house price. So the selling price of the house, you have to add back the $40,000. That is exactly right. You just add the $40,000. And so, yeah, it just ups it to 162, 655, 14. Must be the final answer.
Oh, you're really not going to go over it?
Does that make sense?
Yes.
So that down payment is in addition to what the bank loaned you for the total selling price of the house. 162, 655. There it is. Round to the nearest dollar. So they had us round to the nearest dollar. As I said right here, round to the nearest dollar. 162, 655. Yep. There we go. We got it. Makes sense on all that? Like you could do that on exam day and Tuesday?
It'll be long.
I guess we'll see how good this.
Gilmore family just got a home loan for $250,000. The loan is for 30 years at 9% compounded monthly. Find their monthly mortgage payment on the loan rounded to the nearest dollar. So same kind of thing, another one of these. So you know what to do. Let's crank it out. So 23, 30 years at 9%. 30 years, 9%, compounded monthly. Let's write monthly. Well, it's funny. So 250,000. I couldn't see that. 250,000. $250,000 loan. Find their payment. Find their payment. Okay. So it's present value, right? Present value. Present value P. 1 plus. Oh no, 1 minus. I'm doing it wrong. 1 minus 1 plus r over n to the negative nt all over r over n. All right, so do we know the present value?
Yeah,
What's that?
the two,
The 250, huh? That is, the loan is the present value. The bank loans them the money to buy the house now at its present value. So $250,000 is P. P is what I don't know, the payments. That's what I'm trying to figure out. That's what they're asking me. So 1 minus 1 plus the interest rate, 0.09 over N. It's monthly, so N's 12 again. T is 30 years over 0.09 over 12. All right, same thing. Figure the power up here, minus 360. Again, start with the inside. 1 plus 0.09 divided by 12 equals to the power of negative 360 equals, and then you got to grab that denominator. Dividing is upside down multiplying, so grab that denominator, flip it up, multiply by 12, divide by the 0.09, times 12, divided by 0.09, hit, oh, I forgot the 1 minus. Oh, yeah, I forgot that. Don't do that yet. My mistake. My mistake. Yeah. So 1 minus the answer, huh? You got to do 1, right? Because you got to do 1 minus the answer we got here. And then hit equals. And then do this. So finally, then we'll go times 12 divided by 0.09 equals. So then we get all of that, and you'll get some number, right? You'll get 250,000 equals P. And what's the number in the bracket? Somebody got it?
124, 281,
281.
865, and then 7.
All right. And then last step, just divide that, or you can use the answer button. It's even better. 124, 28, 18657. 124, 281, 8657. Boom. And so, what's their payment?
2012, if you
Round it to the nearest dollar.
round it, yeah.
2012. Is that there?
Well, it's B.
Oh, yeah, there it is. 2012.
Yeah, the other answers don't make sense.
All right. So we got that one. 2 more. We good? So 24. Price of a set of tires has steadily increased by 5% for the last 10 years. If the set, so it's kind of like that one we started with where the, what was it, the crimes in Happyville? 50% more, 50% more, 50% more, 50% more. That whole kind of thing. Right away, you know it's a percent increase, huh? Right away, you're thinking, I'm going to use that percent increase formula. That's correct. If a set of tires is currently priced at $6.99, what was the price 10 years ago? So it was some lower price 10 years ago. It went up by 5%, up by 5%, up by 5%, up by 5%, 10 years in a row. And now it's arrived at $6.99. So what was the price way back when?
You're going to help me?
So this one's a little tricky. I want to make sure you guys are getting how this works. This is like inflation or something. So how do you backtrack inflation? How does this work? So remember what our percent increase formula said. It says the new price is 1 plus the percent times the old price, huh? So the new price, what's the percentage here?
0.08. I mean, 05.
5%, so you got to put that in. Here's a mistake I see a lot on the test. People will go 0.5. That's not 5%, that's 50%. Don't make that mistake. Yeah, nothing will come out right. 0.05 times the old price. Let me just keep it like that for now. So in other words, the new price is 1.05 times the old. So it's just about like the crimes in Happyville problem we were doing that was going up 50% every year, except it's 5%. So that was 1.50, this is 1.05. 5% increase every year. Now that's how you would increase it one time. You would multiply by 1.05 one time if you wanted to increase it 5% one time. But we want to increase it 5% how many times?
10 times.
10 times. Last 10 years. So yeah, exactly. Just like we did on the Happyville problem. Like that. Remember? Because that's multiplying by 1.05 10 times, isn't it? Isn't that what that 10 power means? It means 1.05, 1.05, 1.05, etc. 10 times. And every time you multiply by 1.05, it goes up 5%. So now, do we know the new price or the old price? Yeah. Currently priced at $6.99. We know the new price, don't we? What we don't know is the old price 10 years ago. Some lower price 10 years ago. Right? You tracking with me? So how are we going to solve for old? Solve for old like it's an X. Like it's a big old X. The old word is saying, I want below. So what do we do? Divide by the 1.05 to the 10th. I'm not even going to figure out the 1.05 to the 10th because I don't want some big old decimal right now. I mean, you could totally do it. It's okay. But I just like to keep it a little cleaner. And now I'll just hit the whole thing on my calculator. Just take $6.99 divided by 1.05 to the 10th and hit equals. So I can write that out. So it's going to be $6.99 divided by 1.05 to the power of 10 equals. And so, what do you get? 429?
Yeah.
So the answer is none of the above. 429 is the old price. One more, and we've covered it. All good there. So 429 was the answer, and it was E, none of the above. Okay, so last one, number 25. The dress is on sale for 30% off its regular price. By the way, what's that? Percent decrease.
Yeah.
30% off. That's what a sale is, a percent decrease. So we're going to use one of those, 1 minus percent for decrease, minus instead of plus. In addition, the customer has an extra 10% off coupon. What's that? Percent decrease, again, multiplied by another. Every time you increase or decrease, it's another parenthesis, 1 plus or minus, in this case minus, 10%, 0.10. Bringing the price down to $168. What was the price regularly without any sale or coupons?
Can you add those together?
No, we don't add.
40. The 40, could you add the percentage?
Yeah.
No, it's not
You have to
true.
be separate.
Yeah, you can show mathematically it's not the same thing.
Yeah.
Yeah, so what we have to do, so remember the formula, the new price is 1 minus percent times the old. That's the decrease. That's the percent decrease. So the percent increase is 1 plus, percent decrease is 1 minus. Okay, so, but in this case we're decreasing twice. So we're going to go 1 minus 30%, 0.30. Then we're going to decrease 10% after that, 1 minus 0.10 times the old. There's 2 decreases, so 2 parenthesis multiplication. 1 minus the decimal, 1 minus the decimal. Is that making sense? So the new price will be 0.70 times 0.90 times the old price. By the way, doesn't that make sense for a second? If I can give you one more, make sense of it. If a price goes down 30%, what if I said, hey, 30% of the class is not here today? What percentage is here? 70%. If the attendance goes down 30% then it's 70% of what it used to be. So if the price dropped 30%, of course it's 70% of what it used to be. We should think of that automatically. If they lower a price 30%, then it's 70% of, what's that, times what it used to be, the old price. Of course that's right. And if the coupon is 10% off, then it's 90% of times what it used to be. Of course that's right. Right? And now, do we know the new or the old? The price, yeah, this is the new price. The price came down to 168. So 168 is the new price. Right? So if you multiply those together, don't you get 0.063? No, just 0.63. 0.63? Yeah. Times the old. We good there. If you just multiply 0.7 times 0.9. How do you finish solving for old there? Just divide by the 0.63. Boom, right? So what's the number?
A.
Is it A? 200. So the old price, the price before all those discounts, must have been $267. And those two discounts brought it down. So the old price was $267.